Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we finished numerical analysis, and I hope that topic is clear with all of you. All you have to do in there is just remember the formulas, and you should know how to apply them in the questions. That's all for the numerical analysis one. Today, we'll start with the new topic, which is probability. Most of you, or almost all of you, knows about probability. This we have been learning from class 10 onwards, and this is the most important topic of statistical analysis or paper one. Probability forms the basis of statistics. Everything that is related to statistics had begun with probability only. So, probability, you should be aware of all the rules and everything that has been taught to you from class 10th till your masters, and that you should be aware of all the rules and regulations for that. Some things we'll do today, but I hope that all must be aware of the laws of probability and everything about it. We'll be solving some of the questions. One of them would be PYQ, so as to know what kind of questions have been asked in the previous years regarding this topic probability. So let us begin. Probability. So probability means something that we are estimating. A probability in simple terms is probability only. That in regular basis or on daily basis, we measure probability while talking to each other. Suppose we have to go to a friend's party, and someone my one of my friend A, which is let us name that friend as A should also come in that party, and I am discussing this with my another friend B. So I and B are discussing whether A will come or not. So this is in simple terms is probability. If I am saying that I am thinking that A will come with not certainty, but I am thinking, then it is the probability that A will come. And B is saying that A will not. He is thinking that A will not come. Then he is saying that it is the probability that I am having the probability that A will not come to the party. Next example is that when we sit with our family or our colleagues, then we say, or with the classmates as well, then we say that today it might rain today, or it might be a sunny day today. So that is also we are talking about probability only, that we are estimating that it might rain. It might not rain that day, but there is a possibility that it might rain. Rest of the examples are only verbals. These are verbal probability. When we come to mathematics, the probability is classified into three important definitions, which is very important from your exam point of view. And first, the definition was of classical or priori probability, which was given by James Bernoulli. Then there were some limitations to that classical probability definition. Then we move forward to another kind of probability, which is second one was mathematical, or we can say that it is empirical probability, where the limitations of A were overcome, and still then there was one or two more limitations that arose, and then came our third probability, which is axiomatic probability, that excludes all the limitations of probabilities and is considered the best definition of probability till date, which was given to us by uh, our famous, very famous mathematician, which is known as A.N. Kolmogorov. Kolmogorov was a good mathematician as well as statistician that gave many theorems, and you must have learned about Kolmogorov in sequence and series, Kolmogorov series, Kolmogorov sequence, all of that. So that's where the uh, probability definition was considered to be not perfect. Nothing is perfect, but the most apt one. So let us discuss about them. So first kind of probability definition was classical all or priori probability. So this definition included that if there are total n outcomes, if there are total n outcomes, and out of n outcomes, total outcomes is equals to n, and m out of n outcomes, n were mutually exclusive, m were mutually exclusive and exhaustive and equally likely. I hope that you know all the meanings of these terms. Mutually exclusive means occurrence of this does not depend on the occurrence of another term and another thing. And exhaustive matlab it will at some point of time it will diminish to zero. And equally likely means that the occurrence of this is equal to the occurrence of the other probability, and total outcomes are n. So this classical probability, suppose we have to find the probability of occurrence of an event A, then it is given as total number of mutually exclusive, exhaustive and equally likely events, or which represent the probability of occurring of A upon total number of outcomes, m upon n. This was considered as the classical probability, or in very simple terms, we can say that probability of occurrence of that event upon total number of events that occurred. That is our classical or priori probability. But the limitations were there. Some of the limitations were that there might not be, every case might not be equally likely. Suppose I am going to give an interview and my chances of getting selected is not half, and my chances of getting rejected is also not half. They Because this is a theoretical question, so we cannot say that my chances of getting selection is 50% and not getting selected is 50%. So that is a wrong concept. That's why here one limitation came. And second one was mutually exclusive one. Suppose we have to perform sample we have to perform the experiment again and again and again and again. So as we reach up till the infinite term, so we are not keeping n. Suppose it is infinite. Suppose n is also equal to infinite. We are not being able to calculate this. Then the probability of the event occurrence will be zero, which is not the case. Suppose I am rolling a dice again and again up to infinite times, which is just a theoretical concept, but in theory also maths is always proving theories. So if n is very large, means reaches up till infinity, then probability of occurrence of A. Suppose I am saying A is the occurrence of sixes in the times n times of dice throws. So 6 must be occur one or two times, at least one time. So it cannot be equal to zero. So this is another limitation, that as and when we increase the n number of terms into infinity, the probability that n number of terms reaches to infinity, then probability of that occurrence of an event does not reach to zero. It is impossible. So this is another limitation of our classical priori probability. This was given by James Bernoulli. It laid the foundation of probability definitions and explanation of probability and many more things, like Bernoulli theorem and everything, and Bernoulli distribution as well. But it was not the correct, it had some limitations. So to overcome these limitations, we had another probability, which was empirical or mathematical probability. empirical probability says that it was given by von Mises. So in empirical probability, the equally likely term was rejected. That it is not possible that ki equally likely term will be occurring in every probability. So that was rejected. And the second one was when we reach when the experiment was performed repeatedly under essentially homogeneous conditions. They said that it should be performed under essentially homogeneous conditions. Means if the conditions are same and we keep on performing the experiment up till infinity, then we'll be getting some probability which will not be equal to zero. So that's how they gave us an empirical probability. And under identical conditions, homogeneous or identical conditions both are similar, then the limiting value of ratio of number of times the event occurs to the number of trials as the number of trials become infinitely large, so that will be not be equal to zero. If we say that probability of occurrence of an event A is equals to m upon n, where n reaches to infinity and not equals to infinity, then it will reach to zero but will not be equal to zero. This is what it states. So this is our empirical probability definition, which is given by von Mises. And the only limitation was its definition only, that it states that under essentially homogeneous conditions. Suppose I am throwing a dice and I will keep on throwing the dice. If I'm sitting in an open space, I'm throwing a dice and I am repeating the experiment again and again. The wind will start moving, there will be rain, and there will be some things, and I will be feeling hungry. So I'll go and eat things. Time will not be same. Day of the year will not be same, and so on. So essential homogeneous condition are realistic are not a realistic assumption to be taken under. So that's why it has this limitation, which empirical probability therefore is not considered the most apt probability definition till now. So here we will move forward to the final definition of probability, which is considered the best till date, which is axiomatic definition of probability. Axiomatic definition of probability states three axioms. Axiom 1, axiom of non-negativity, non-negativity, axiom of certainty, and the third one is axiom of additivity. Suppose there are n number of there are n number of events a I, for all I goes to 1 from 1 to n. So there are n number of events AIs. So axiom of non-negativity states that the probability of AI should always be greater than or equal to 0. It can never be negative, and it should always be greater than equal to 0. Then the second axiom of certainty states that the probability of the sample space should always be equal to 1. The third axiom of additivity states that if we take the probability of multiplication of all the events where I goes from 1 to n, then it should be equal to the summation of all the events from I goes to from 1 to n of the probability of that event ai. That is our axiom of additivity. And this axiom definition of probability was given by A. N. Kolmogorov. It was given by A.N. Kolmogorov. And this axiom definition of probability has been many times asked in the examination, as it is the definition only, nothing else from the definition. And they might ask you as well the limitations of the previous two, not the exact definition but the limitations. Why is it not considered apt? So this was the important concept of probability. Now let us do some questions on probability only. So here there is one question in which a student appears in CAT. There are two possibilities. He clears it or fails it. So the probability of his being selected. Suppose the event is that he is selected. There are two possibilities. So probability of occurrence of A is that he is selected. Chances that he is selected upon total outcomes. One outcome is selection. There are two outcomes here. One is being selected, and the second one is being rejected. Let us say it is probability of A and it is event A bar. Event A is that the student is selected, and event A bar is that the student is rejected. Then we have to state that probability of occurrence of A is that it is selected, the event of occurrence of A, upon the total outcomes. So we know that it is selected. There are two outcomes. Probability of him being selected is 1 and the total outcome is 2. So our answer will be 1 by 2, which is option number A. It was an easier one based on classical probability definition. Now here comes the second question, in which if two dice are rolled, which one of the following is the probability that the sum of score is 11? Now in this question, if two dice are rolled, here the outcomes, I am stating the outcomes. What will be the outcomes of two dicing being rolled? First dice appears with 1, second also appears with 1. First appears with 1, second with 2. First with 1, second with 3. First with 1, second with 4. First with 1 and second with 5. And so on. We'll draw all the outcomes that can possibly occur. 2 2, 3 2, 4 2, 5 2, 6 2, 2 3, 2 4, 2 5, 3 3, 3 4, 3 5, 3 6, 3 4, 3 5, and one more will be there, 1 and 6, 2 and 6, 3 and 6, 4 4, 4 5, 4 6. It will be 4 3. Okay, I have done it wrong here. 4 3, 5 3, 6 3, 5 4, 6 4, 5 5, 5 6, 6 6, and 6 5. I hope that you must be knowing how I have done it. I've just taken the total number of outcomes that can possibly occur when we roll two dices. If one dice has 1, then the second is also has 1. One dice has 1, then the second one has 2, and all those things. Now they have asked you that the sum of the scores is 11. Now here we see that the sum of score 11s occurs in these two terms only, 6, 5 and 5, 6. Nothing else matches. Below them are all lesser than 11 and above them is 1, which is 6 and 6. If we sum them, they'll be 20, they'll be 12. So here the total number of outcomes 6 into 6 will be 36. So the probability of occurrence of 11 will be, how many outcomes are occurring? 1 and 2, 5, 6 and 6, 5, which is 2. And total number of outcomes is 6 into 6, which is 36, which comes out to be 1 upon 18. Our option number C is correct. That's how you attempt the question in examination. Now there is another type of the same question in which two unbiased dice are rolled once. The probability that difference in digits on their upper faces is 0. Now difference in digits on their upper face is 0, which means that if one has 1 on its upper face and the second one also has the one on the upper face, then their difference will be 0. If one has 1 and the second one has 2, then their difference will not be equal to 0, right? So we have to see all the numbers which are same occurring similarly in our table. I'm not drawing it again, we can do it from here only. So 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5 and 6 and 6. 1, 2, 3, 4, 5, 6. There are 6 outcomes. So probability of occurrence of 0 on the top is 6 and total number of outcome was 36. So our answer will be 1 upon 6, which is our option number B, 1 upon 6. Now moving forward to one of the PYQs that has been asked in your examination, ISS examination 2021. Here they state that 60 persons among whom A and B are seated at a round table. So there are 60 persons. This is a round table and there are 60 persons sitting here. So let us say A is sitting here and B is sitting here and rest other 14 persons are sitting here. And what is the probability that 4 persons are seated between A and B? 4 persons can seated here, 4 persons can be seated here, anywhere. Let us say that because space here is lesser, let us say that they are sitting below and rest other 10 people are sitting here. 10 plus 4 plus 2 will be equal to 16. So the when anyone is seated on a round table, just know that total outcomes, total ways that they can be seated on a round table will be n minus 1 factorial. Total number of people are 16, so it will be 16 minus 1 factorial, which is equals to 15 factorial. Now 4% sits between A and B. So 4% probability that 4% can sit between A and B is 4 factorial. And probability that 2% can probability, first of all, we have fixed the seats of two, A and B. Now, out of A and if we get them out of the rest other, 16 minus 2 is 14. And we have to place 4 persons. So, probability of fixing 4 persons will be 14 C4. The rest one C4 into 4% can shift between their places. So that is 4 factorial. And the rest 10% which are sitting above can also shift between their places. That is 10 factorial. And if A and B are seated here, but if B is seated here and A is seated here, then also the arrangement will change. So there are two cases. So we'll multiply it by 2. So the probability of occurrence of that 4% sits between A and B is this upon total outcomes, which is 15 factorial, which gives our answer as on solving as 2 by 15. You can solve it on your own. Tell a NCR is n factorial upon n minus r factorial into r factorial, where n factorial is equals to n minus 1, n minus 2 up till 1. All of them are multiplied. So this was your PYQ, which has been asked in 2021. This is how probability questions come in the examination. I hope that the topic is clear. And if not, you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.